Hello class and welcome to today's lesson on 4.6. Today we're going to talk about a word that we talked about a lot in this chapter already. Right, that word is outliers. That's right. Today students will be able to calculate outliers and how they affect data. Our essential question, which piece of data is affected the most by outliers? So to start, right, some review here, right? We talked about mean before in this class and in previous classes, right? Mean more than just the average, right? What we want to think about it is it tells us how large each value would be if each individual had the same value, sometimes called the fair share value. So right, a good example, think about it this way, right? An example, amount of pets students have. So notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9 students, right? These are all the amount of pets that they have. So if we want to find the average here, we're going to add these all up. So right, we add these numbers up. So 1 plus 3 plus 4 plus 4 plus 4 plus 5 plus 7 plus 8 plus 9. Right, that gets us 45. And we're going to divide by the 9 students. This gives us an answer of 5. So right, let's think of this in terms of what we have up above. It's stating that, it's not saying, the best way to think about it is fair share, right? If we were to take all 45 pets, we could split them evenly to each of the 9 people and each of them would get 5 pets, right? So that's a good way to think about how average works. So to calculate an outlier, right, important piece here, and this has our formulas that we use for it. So right, an outlier is any data point that is 1.5 times the IQR above or below our Q1 and our Q3. Right, so we've talked about our first quartile and our third quartile. Right, we talked about the interquartile range, right, that's Q3 minus Q1, right, it's the range of our quartiles. And we're gonna, that 1.5 is staying there every single time. So let's look at this data here. Right, first we need to find the median. So right, 1, 2, 3, 4, 5, 6, 7, 8, 9 data pieces. So our median is there. If I'm trying to find, right, Q1, it is in the middle there, average of 12 and 12. So that makes Q1, we'll use green here to color coordinate. Right, Q1 is equal to 12. And we do the same thing for our upper limit here, right? We take the average of these two. We find Q3 to equal 20. So right, if we have a Q3 of 20 and a Q1 of 12, that means our IQR is going to be 20 minus 12 or 8. So we'll fill in this information here. So now what we can do is we can double check to see, hey, is this number an outlier or not? So let's look for our lower limit first, right? We're going to check to see, do we have one that's below our first quartile, right? Is it 1.5 times the IQR below our first quartile? So we take 12 minus 1.5 times our IQR of 8. Right, so when we think about this, right, 12 is going to stay as a 12. 1.5 times 8, right, that gives us 12. 12 minus 12 is 0. I'll get to what we do once we go through this second one here. So on the second one, right, we're taking 20. This time we're adding 1.5 times our IQR. Notice this number right here is the same for both of our values, right? It's 1.5 times our IQR. So in this case, we got 20 plus 12, and we get an answer of 32. So now what do we do with those numbers? So what we're checking is to see, do we have any data pieces that lie outside of those two values? So right, think about like a number line here. We have the number 0, going all the way to 32, and any numbers inside of here are good to go, right? Including 0 or 32. including 0 or 32. Our question is looking at our data, right, our original data, so I'll erase this real quick. Looking at our original data, do we have any data pieces here that are outside of our range, right, that are outside of our range from 0 to 32? And in fact, we do, right, we have this outlier here of 42. And so we would say 42 is an outlier, right? Remember, outlier, why we call it that? Because it lies outside of the rest of our data, right? It lies outside of the rest of our data. Right? Sometimes you don't have to, right? Maybe if you looked at this one, you might have been able to tell that it's an outlier, right? Some examples are kind of obvious, right? If we look at this first one here, right? We look at this data and go, okay, is there an outlier? Right? Yes, there is. And right, it's going to be 40. Right? So you could work through that one, right? Figure out, but you would end up finding that, hey, yes, this one is 40. So now let's try this one together here. Right, we have this data set, so we're going to find our median. So right, first we notice, well, our median is in between those two values. So we take those two and find the sum, or the average of them, and we find our median to be 4.5. So now if I want to find Q1, right, I use that 4, and I include it here, and I take the average of those two values, and I find it to be 2. Do the same thing over here. I take the average of those two values, find it to be 8.5, which makes our IQR 6.5. So now we use this information to help us out. Right? We take 2 minus 1.5 times 6.5. And if we do that, we get negative 7.75. Do the same thing down here. So 8.5 plus 1.5 times 6.5. We get an answer of 18.25. So right, our question is, do we, one, right, if you think about a number line, negative 7.75, 18.25, we're asking ourselves, do we have any values that land on the outside of here? And right, all of our values are from 1 to 9, so they're all fitting somewhere in here. And so we're good to go. So right, we have no outliers for this problem. So comparing, right, the previous two problems. Comparing the previous two problems. Right, so notice the one we just talked about, the one we just did, our mean, right, if we took the mean, which we know how to find, right, add them all up, take the average, you'd get 5. If we were to take the median, right, find the middle number, we'd get it to be 4.5. So now we can do the same for this data set, right, with an outlier. We're asking ourselves, if you add in an outlier, which does it affect the most? Well, right, let's compare the two. If we find the average or the mean of this data set, you find your mean to be 8.9. If you find the median or the middle number, right, it's going to be 5. So looking at this information, right, comparing our means and our medians with the addition of an outlier into our data set, notice which one changes the most, right? Which one changes the most? And right, this is getting to our central question here, right? Our central question was, what gets affected the most by an outlier? And that answer is going to be a mean, right? The answer is a mean. And this piece of information is very important. It says when a data set has outliers, the median is a better measure of where the center of the data is than the mean. Reason being, right, this gets affected the most, by outliers. Right? It's affected the most by outliers. So 2 more examples here. Right, so we look at this one, it says the mean and the median are 2 different ways to describe the center distribution. Which is a better description of the data set? So we look at this one and go, okay, first I need to find the median, which I have. Now I'm going to find our Q1, find our Q3. Right, so our Q1 is 3.5. Our Q3 is 7.5. And right, what we would do now, right, we would plug them into our formula. Right, going back to this real quick, right, it's Q1, so 3.5 minus 1.5 times, forgot to put this up here, right, our IQR in this situation would equal 4. That's right, times 4. Get an answer, right, that's going to be our lower limit. Then we'll do the same thing here. And so looking at this, if we were to check both of these answers here, right, so if we take 1.5 times 4, so 3.5 minus 6, we get an answer of negative 2.5 for our lower limit, and then 13.5 for our upper limit. And so we check our data set. Do we have anything that is less than negative 2.5 or greater than 13.5, right? The answer is no. So since we have no outliers saying which is a better description, it's going to be the mean. Going to be the mean. So right, if there's an outlier, the better description is the median. If there is no outlier, we're going to use the mean. Right? The average is going to be the best way to talk about center. So one more example here, right? Real quick one. Notice this data set, right? You could work through it. Some of them are very obvious, right? This one should be pretty obvious that this is an outlier. And so when we think about this question, which is a better description of the center of this data set, it would be our median. And the question is why? Because we have an outlier. Because we have an outlier. So right, key thing there, understanding how an outlier affects our center and which one to use when we're trying to find the best description for center. So that is it for today's lesson on 4.6, talking about outliers.